Last week we started with sequences, and before that we covered how a function executes in Python, and we looked at the return values as well as scope rules. And after that we started with the strings. We discussed slicing, concatenation and repetition, and we did similar thing with tuples in the tutorial. Today's lecture will talk more about sequences. So first we will talk more about slicing. So just like indices can be negative in Python, it is also possible to have negative indices for slicing. Okay, and to understand negative indices, it's always better, at least at the start, to draw this diagram where you have a string and you have indices written in the positive direction as well as in the negative direction. So remember, the last item corresponds to index -1 and then second last -2 and so on. Okay. So once you have this diagram, it's easy to find out slices as well. So for example, the slice -4 colon -1 corresponds to this particular range in the string. So it goes all the way up to last index, but not including the last index, which means name of -4 colon -1 will include C, A and D, but not S, which is at -1. So name -4 colon -1, this slice will result in a value CAD. We can also use the feature optional indices. So if I leave second index blank, it means all the way up to and including the last character. So the corresponding value becomes CADS. It is also allowed to mix negative and positive indices for slice. So once again, it will help if you have this diagram ready. So when I say name -4 colon 4, I start with an index -4 and go all the way to the index 4. Okay. So this again means the same slice which we had seen earlier, the value C, A and D. Okay. So let's look at some more rules of this and then I will take some questions if there are any. So whenever during slicing, if you include indices which are not part of the string, you get so in case of indexing, if you have an index which is out of range of string, then you get an error. But in case of slicing, such indices are ignored. Similarly, other rule is that when start and end have same sign, if start is greater than end, so start lies towards the right of end, in that case also slice is ignored. So you get an empty slice for out of range indices as well as start greater than end. So let's look at some examples. So if I say name ACADS and then I ask for slice which starts at 4 and ends at index 50, you can see that the initial index is at place 4. Okay. And then I am going all the way to 50, which does not even belong to the string. So in such case, all such indices will be ignored and I am already getting a value of S, which corresponds to valid index only. If I want slice 40 colon 50 of name, in that case, since there is not a single valid index in this slice, I will get an empty string. If I take a very small index followed by a very large index, in that case I will get the full string because indices which are smaller than 0 and greater than 4 are ignored. Okay, smaller than 0 in the sense both in the negative direction as well as in the positive direction. So when I say index -50 colon 20, I am really going for a slice which extends very much towards the left to very much towards the right. So I will only end up with the exact string, that is our input string or the target string. Okay. Some more examples. If I have minus 450 colon minus 20. In this case again I get a negative empty string because indices are out of range, and same with the positive strings. In fact, in this case there are two issues. One is that start is bigger than end, and secondly, even if we consider individual indices, they are outside the range. Finally, if I say my 1 colon minus 1, now this is something interesting. In this case, even though it looks like start is greater than end, we are still getting some non-empty slice, and that is because we are mixing slices. In this case, the rule start greater than end does not apply. So remember, start greater than end rule applies only when both start and end have the same sign. If you mix the signs, in that case it's better to convert it to same sign and then only apply this rule. Okay. So if there are any questions about slicing, please ask. Please raise your hand. So in this case we get a value CAD in the last case, because if you look at the diagram, 1 starts here, the index 1 is here and index minus 1 is here. So I get everything from start point up to end point, but not including end point. So this gives me CAD. Okay. So slicing is a very powerful concept in Python, and this is one of the nice features of Python, that you can get substrings of strings very easily and you can do some manipulations. And like any other expression, you need not put constant values for start and end in case of slice. You can also have expressions which return integer value. Okay. So with this, let's go to ACAD site and attempt quiz number 24. Okay, so let's end the quiz and let's come back to the session. So before we move on, let's discuss the solution. Okay, so in this case, you just have to draw the diagram as I said, as I showed in the example. Only interesting case was I have given something which was not discussed in the class. So optional third argument in one of the slides. This one. So Python allows you to even tell about the step argument or stride argument. In this case, just like the range function, Python will only pick elements which lie at distance given by the third argument. And this is a nice way of reversing a string. So if I say some string, then colon minus 1, I will get the reverse of the string. So we already discussed tuples in the tutorial, so I will just go over them very quickly. So tuples consist of number of values separated by commas. So for example, here is a tuple T, and I can index it very similar to how I index a string, but instead of single characters, I will get individual components of the tuple. So everything which is separated by comma. The type of tuple is also called tuple. Okay. And when you print a tuple in Python, you get these elements separated by comma within round parenthesis. Okay. So if you have want an empty tuple, you just have to assign opening parenthesis and closing parenthesis to a variable. To get a singleton tuple, you cannot just say a value inside parenthesis, because as you know, in Python, parenthesis around an expression just helps in deciding its precedence. Okay, it does not change the meaning of the expression. So if you just say within parenthesis 1, this also means the value 1. It does not mean a tuple containing a single value 1. To create a tuple, you have to put an optional comma at the end if you are interested in only a singleton tuple. So either 1 comma or 1 comma within parenthesis will give you a singleton tuple. So this is something very important, and it's easy to miss when you are creating tuples programmatically. Tuples can be nested. So for example, I can have a tuple inside a tuple. So in this case, a student tuple consists of Prasanna 34 and another tuple called course. Okay, if I try to print student, I will get nested parenthesis. So all this is very interesting because, and again, it follows the type rules of Python or any other programming language in general, where you can replace a value by any other equivalent value of similar type. Okay. So the thing to note here is the tuple course is copied into tuple student. Okay. So course itself is different from the value which gets inside tuple student, which means if I later change tuple course to some other course, it does not change my student tuple. Okay, it still remains the same. So this is another thing to remember, that tuples are copied by value. Okay. And this was also discussed in tutorial, that similar to string, we can apply length function to tuple and it gives you number of elements in the tuple. So in this case, length of course is 3 because I have 3 different values. Length of student is also 3 because even though it contains course tuple inside it, the number of elements in student is just 3. It's the name Prasanna followed by 34, which is probably his age, and followed by a single value of type tuple called course. Okay, so length of student is also 3, and as expected, length of empty is 0 and length of singleton tuple that we created earlier is 1. So any questions on tuples? Okay, so we'll move forward then. Just like string, because tuples are also sequences, they can be concatenated, repeated, indexed and slide. So there is one question, is tuple immutable? Yes, tuple is immutable. You cannot change contents of a tuple, and we will discuss it in details once we finish lists. Okay, so here are some examples. So we can do course 1 plus course 2, and it adds all the components of course 1 followed by components of course 2. The result is a new tuple. Okay, it does not modify either course 1 or course 2. So concatenation does not modify existing tuples. In fact, as we discussed just now, existing tuples cannot be modified. They are immutable. And you can also do nested operation like concatenation followed by slicing, concatenation followed by indexing, and so on. Okay, so the rules are very similar to rules for string. Just remember that instead of single characters, you will get elements of the tuples when you do slicing and indexing. Okay. Okay, so let's have a quick quiz on tuples. So we'll spend a few minutes on quiz number 25. Okay, so let's look at the answers for this quiz. The first, in fact the order might be different for you, so I am discussing what is shown on my screen. The first expression is len of hello comma world. So we have a tuple which contains 2 strings, but the function len is called on the tuple. So note that there is a sequence of 2 parentheses. The first parenthesis corresponds to function len, the second parenthesis corresponds to the tuple hello world. So in this case length has to be 2 because it contains 2 elements. Len of 1, 2, 3, 4, 5. So here we have not given 1, 2, 3, 4, 5 inside parenthesis, which means this len is applied on 5 arguments. However, length function expects only one sequence as its parameter, as its argument. So we will get an error saying that len cannot take more than 1 arguments. Similarly, the third one, where we are passing a single value integer 1, this is also a bad usage of length because length expects a sequence. So the error will be slightly different. In this case, we are passing a single argument which is of incorrect type. Okay, so the error messages are approximate. They are not what is produced by Python. Finally, when I call len on hello and followed by a comma, so I have a tuple which contains a single string hello. Length of this tuple is 1. A very confusing thing, a very similar expression where I am calling len on hello without a comma following it. In this case, the inner expression evaluates to a string hello, and length on string hello will give us 5 because it contains 5 characters. Okay, so the last two examples are demonstrate the thing that I said, that it becomes really confusing if you forget putting a comma while creating a singleton. Okay, so any questions on this? Please raise your hand so that I can discuss it. Okay. So since there are no questions, let's move forward. And what we get next is unpacking of sequences. So Python allows us to do several operations on sequences like indexing, slicing, concatenation, repetition, and few more operations. One of the very important operation is unpacking. So you really don't need to index all the elements of a string or tuple if you know its length. What you can use is called unpacking operation, and this unpacking operation we have been seeing in disguise as multiple assignment statement. Okay, so whenever you have an assignment statement where right hand side is a sequence, you can assign every element of right hand side to multiple values on left hand side, provided the number of elements on both sides are same. So some examples are, if I have a student tuple as discussed earlier, which is Prasanna 34, and inside that another tuple Python Ame course number, I can assign this tuple to 3 different elements on the left hand side in a single assignment, which is called multiple assignment, name, role, and registered course. Okay. So after this assignment, the values on the variables on left will get corresponding elements on the right. So which means name will get the first element in the sequence, role will get the second element in the sequence, and this course will get the third element, which happens to be a complete tuple in this case. Okay, so we can just verify this by printing different values. If I print name, I get Prasanna. If I print role, it prints 34. And if I print registered course, it gives me the tuple. Okay. Remember that we cannot assign any, we cannot define more or less variables on the left hand side. They have to match, number of variables have to match exactly the length of the sequence on the right hand side. Okay. So I can also say x1, x2, x3, x4 equal to some string, and in this case individual character of the strings will get assigned to individual values. Okay, so if I now want to print x1, x2, x3, x4, I will get a, m, e, y separately. Okay, so once again I have to fix the expression. Okay, so any questions? So let's have another quick quiz. So sequences and all these operations give opportunity to have a lot of quizzes, and we'll have another quiz on a cat site, quiz number 26. So we have 2 questions in this quiz, so let's discuss the answer. In the first program, you can see that instead of discussing things in class, I have given a slightly more complicated multiple assignment. In this case, left hand side itself has nested tuples or nested variables. Okay, so the rules are very simple. You try to match individual elements in the nested fashion. So x gets matched with hello, and since you can match hello with x, x will get a value hello. The tuple y1 comma y2 will get a value string AK. Now this itself will work as a multiple assignment where y1 will get value of A and y2 will get value of K. Okay, so this means when I try to print y1, it will give me answer A. So Python does allow nested elements on the left hand side of an assignment statement. The catch is that at every level of nesting, the length of left hand side, the number of variables on left hand side, and the length of right hand side expression should match. Okay. So the second one is pretty easy compared to the first one. In this case, x gets assigned value 1 and y gets assigned the complete tuple 2, 4. Okay, so we have a single variable y on left hand side and we have a value which happens to be a tuple containing more than one element. However, the value can be assigned to a variable. So the value of y becomes 2, 4. So if there are any questions, please raise your hand. So let's move on to the next topic. And next topic is something many people have been waiting for so long, and this is list. Okay, list is an ordered sequence of values, and these values are written as a sequence of comma separated values between square bracket. So if you look cursorily, they look very similar to a tuple. Okay. In case of tuples as well as in case of list, we can have elements that are of different types. So we can mix integers with tuples, with strings and so on. We have already seen this with tuple. And in case of list also, we can have values that are of different type. But most often you will find that all the items in a list have same type. Typically lists are generated programmatically. So all the items happen to be of same type, though this is not a restriction. Okay, so here is an example of a list. Only difference you can see from tuple as of now is use of square bracket instead of round brackets. Other than that, it looks very similar to a tuple. Okay, but if you try to print the type, you will get type list. Okay. So if you visually a list and a tuple look very similar, but as some people are talking about mutation, we'll come to that very soon. Okay, lists are very different from tuples in their usage. But lists are also sequence type, which means sequence operations are applicable. What that means is you can have a list and you can find out length of that list. You can ask for specific values at specific index. So fib of 3 is 3, and once again remember indexing is 0 based. So fib of 0 is 1, fib of 1 is 1, and so on. You can slice using same syntax as strings or tuples. So fib 3 colon will give me all elements starting from the element at index 3. So this will give me complete list 3, 5, 8 up to 55. And I can even do concatenation. So I can add 0 at the start. So some people like Fibonacci numbers to start at 0. I can repeat a list. So I can say, okay, I want this list repeated 3 times, 1, 1, 2. Okay. And I can do unpacking with list as well. Again, the same rules apply. The number of elements on the left have to be exactly same as the length of the list. So I get 1, 1, 2. So, okay. So up to this, things are quite similar to what we discussed earlier, but lists have few more important operations, and I will just list them here, and you can try them, or you can consult the documentation that I will suggest in a few slides. Okay. So list allow appending an element at the end. List, you can extend list with a sequence. Some of the examples we will see, which means every element in the list, in the sequence SEQ, will get added at the end of the list L. Similarly, when we say L dot append X, X value will get added at the end of the list. I can also insert a value X at a fixed position I, which means after this insertion, position I will be occupied by element X. All existing element at I and later position will shift to right. Okay. But once again, we have to make sure this I is a valid index. It's not out of bound of list. I can remove a value at an value X from the list. So this will remove first occurrence in the list. I can remove element at an index I using pop operation, or I can say remove the last element by skipping the value I. Okay, the I is optional. If you don't give I, then it skips over, it removes the last element. Then you have L dot index X. This gives you the index corresponding to first occurrence of X. You have L dot count X. It tells you number of occurrences of X. You can sort a list. Okay, so this is the simple form in which it will give a natural ordering on the elements. And you can reverse a list. Again, it will be the order of elements in the list will be reversed. The last element will become first and so on. Okay. So in this slide, the important thing to note is all the functions which are written in red, they modify the list itself, list L itself. Okay. This was not possible with tuples and string, but in case of list, you can modify the list. The functions in black do not change the list itself. They will just give some property of the list. Okay. The functions sort and reverse, I have put them in bold because they are very useful functions and they are used quite a few in the programming programs. Okay. So any question about these functions? And I encourage you to try these functions, read the documentation to understand the nitty-gritties of this function, what kind of exceptions are generated if you do not put indices within the range and so on. Okay. So I think I will skip on quiz 27 at this point, and we'll come back to it, but let's discuss the mutability. Okay, so there is one question, question by Tejas. He is asking, in what situation do you prefer tuple over a list? Okay, so to answer this, I will have to discuss mutability and immutability first, and then I will come back to this question. Okay, so the very next slide is about mutable and immutable types. So we saw that tuples and list types look very similar. However, there is one very big difference. Lists are mutable and tuples and strings are immutable. What that means is the contents of a list can be modified. We saw several functions which can modify the contents, but contents of tuples and strings cannot be modified. Again, so what is the big deal about it? Why do we say that this is a very important feature? So the idea here is that since you cannot modify tuples, okay, it is possible for Python to do quite a bit of optimization when you are using tuples. So if you pass a tuple as a parameter or as a return value, Python knows that this tuple cannot be changed by the caller or the callee or anywhere in the program. So it can do certain kind of optimizations. Okay. However, in case of list, since list can be modified at any point, Python cannot make assumptions about the contents of the list. It has to make sure it follows certain discipline. Okay. Now, another important thing is about programming discipline. So this is very similar to having a sensitive document. Okay. So for example, your ID proof. If someone wants to have your ID proof to do some verification, you are most likely not going to give him the original ID, otherwise he or she can destroy it. Okay. So it's always a good idea to give a copy of the ID, right? so that even if the other person can destroy it, you still have your original copy safe. So same is the problem with list. If you pass a list to some function which is an insecure function or which is an unknown function, you don't know its behavior, there is a possibility that this unknown function modifies the list that is being passed, and you will start working with modifying list without even knowing about the modification. Okay. In such cases, it is more desirable to pass a mutable, immutable object like tuple or string, so that the unknown function cannot modify the object. Okay. So this is one of the major scenario. These are the two major scenarios. One, if you want a function to modify the data or the object, in that case you have to use string. If a function does not, if you don't want a function to modify your object, then it's better to pass a tuple. Okay. So there is one more question. Do we need to worry about concurrency in Python, or is it always single threaded? So in this course, we do not have to worry about concurrency. So all the programs which we will write are single threaded. But in fact, in some advanced courses, some parallel things will come into picture. Or I may even ask Prasanna that towards the end, we can have some assignments which will work on parallel map reduce kind of paradigm where you have concurrent functions. Okay. So rule of thumb is, if you want others to change your data, use list. If you don't want others to change your data, use tuples. And in case you are not sure, always use tuples. Okay. The reason being, if your program breaks because you cannot modify your tuple, you can always change it to a list. But you start with a list, you will never even know whether the right capability was really desired or not, and it might result in some slowdown of your program. Okay. So let's have a little bit of more of discussion on mutable and immutable type to understand this, because the example I'm going to show you has will show some issues with mutability versus immutability. So suppose I want to create a program which keeps track of games, indoor games as well as outdoor games. So I create a list of indoor games. Maybe I want to add more games to the list later, and similarly outdoor games. And then I create a tuple which holds both indoor as well as outdoor games. Okay, so I have two lists in this tuple, one which contains indoor games, another one which contains outdoor games. Okay. So when I print this list, I get the values as expected. Now someone asked me to modify my program and add card games as well. Okay. So even though I am doing all this in a Python shell, you can very well see a scenario where this has to be done in a program, in a script. So now I have to add card games to the tuple. Okay. At this point I have some issues. So, but let's just look at what games does. So game 0 gives me the contents of first component, which happens to be indoor games, badminton, table tennis and carom. And note that games is a tuple. Okay. So if I want to change games 0 to card games, this will not work. The simple reason being, games tuple is immutable. Python will throw back an error at me saying that tuple object does not support assignment. Okay. So even though I can print the item, I cannot change it. So to solve this problem, I create another copy or another tuple called games1, in which I have all three lists: indoor games list, outdoor games list and card games list. And just to verify things are fine, I try to do certain operations. So for example, slicing works, and I'm also making sure that games1, the first two components are same as the variable games. So first component is indoor games, second component is outdoor games in games1 as well as games2. So the two tuples match. Okay. The slice of games 1 matches the games. Okay. So Anirudh has asked a question, can you append card to games list? No, we cannot append. In fact, games cannot be changed at all. We cannot add an element, we cannot delete an element, we cannot extend it, we cannot replace any element and so on. Okay. So games is a tuple, games 1 is also a tuple. But what I wanted to show is something interesting. Someone asked me to update outdoor games as well, to include hockey in outdoor games as well. So earlier it was just football and cricket, now it is hockey. And what has happened just now? Something which was working earlier, games 1, first 2 elements were same as games. Suddenly I see that this is resulting in a false statement. Okay. So what went wrong? Though I am saying that I cannot change games at all, something has happened in between these 2 statements that has changed my tuple games between this statement and this statement. So only thing I did was assign a new outdoor game to the outdoor list, but unexpectedly games tuple has also changed, if I can say so. So games tuple now contains hockey and cricket in the outdoor games instead of football and cricket. So why did this tuple games change when we changed the list outdoor? So I would have expected just outdoor to change, but not games, because I keep on saying games is immutable, games is, or tuples are immutable. Okay. So this is the thing I wanted to bring your attention to. And let's look at this more carefully. So when I say games tuple is immutable, you have to remember that games contains pointers or references to list indoor and outdoor. Okay. And therefore when I change outdoor list, the tuple itself has not changed. However, the contents of list inside the tuple, and this list is mutable, has changed. Okay. So this is something like games is an envelope which contains address of some house. The address on the house did not change, the address on the envelope did not change, but probably people inside the house shifted. Someone came in or someone moved out. Okay. So but then games 1 should also have changed, right? But this is not so, because remember, in case of games 1, I created explicitly a copy of list indoor and outdoor. I typed them by hand rather than referring to indoor and outdoor. Okay, so games 1 contains references to some other list. These 2 lists happen to have same content as indoor and outdoor, but modifying indoor or outdoor will not change this separate copy. Okay, and let's look at this pictorially. So suppose this cloud is my memory, RAM in my system, and first I created a list football cricket, and I said variable outdoor will refer to this memory where football and cricket are stored. I created another list badminton, table tennis and carom, and I said okay, indoor variable will refer to this list. Remember, in Python variables only mean binding, they just refer to certain memory location. Okay, and finally I created a tuple. Within this tuple I made reference to indoor and outdoor, which means I am referring to the list held by indoor and outdoor, and I called this list this tuple games. Okay. Next I created another tuple which contained new set of items, which contains another list for indoor games and another list for outdoor games, but I am not directly referring to variables indoor and outdoor, so I create new memory locations to hold these lists. Okay, and when I change football cricket to hockey cricket using the handle outdoor, I overwrote on the list which was pointed by outdoor. Okay, so once again let's look at this animation. So this particular portion which was pointed by variable outdoor, I changed it by changing content of 0th index to hockey. As a result, the list got updated, and as a result, the tuple games also looks to us as if it has got changed, even though you can see that none of the pointers held by games got updated. Okay, so even though the outer tuple is immutable, it contains references to a list which happen to be mutable, and it is possible to change it. Okay, so I suppose this example has made it clear. If there are any questions, please ask. Okay, and as you can see that it is possible to update contents of list which are there in games 1 as well. Okay, so I cannot change games 1 itself, but the first component of games 1 happens to be a list, and I can update 0th component of that list. I can make it hockey, and at this point both games 1 and games 2 happen to have hockey as part of their outdoor games. Okay, so it is not necessary to have variables to refer to this list. You can also refer to them using indexing. Okay, and after this change, both games 1 and games 2 point to the same indoor and outdoor games. Okay, so I will take a break here and I will unmute Professor Greg and make him the presenter.
Okay. So, thank you. I will just turn on my camera and show my screen. So I'm going to say a couple words about my course, Data Science for Managers, which I believe is scheduled to run in the spring, and it should be up on everybody's screen now. I've got some PowerPoint slides. So what I'll do here for the next couple of minutes is say a couple of words about myself, talk a little bit about some of the topics that we're going to cover in the course, the pedagogy for the course, some of the industries and areas that would be covered through the examples in the course, go over a couple of examples that we will be looking into in a little bit more detail, and then try to make a case for why you'd want to know all this as a modern manager. So first of all, the instructor, this is me. My day job is I'm a professor of management science at the Ivey Business School at the University of Western Ontario. I teach in our analytics group at the undergraduate MBA, executive MBA, and PhD level in a variety of analytics courses. And in particular, this course, Data Science for Managers, is one that I've taught to our full-time MBA students for the last 2 years now. My background is actuarial science, management science, and industrial engineering. Some of the topics that we'll cover in this course are what I would consider a lot of the fundamental topics that would give you an overview of things that are generally associated with data science and data mining. So we'll talk about classification and prediction. And then in terms of specific methodologies, we'll be talking about linear regression, logistic regression, k-nearest neighbors, classification and regression trees, clustering algorithms, and neural networks. The pedagogy, first of all, on the materials, we'll be using the textbook Data Mining for Business Analytics by Schmealy, Bruce, and Patel. And this is a very nice textbook that has descriptions of all of the methods that I've just covered, as well as a whole lot of other methods that we wouldn't have time to get into in this course, and a very large list of examples and data sets that you can use to practice and work through. The course itself is going to be delivered as a mixture of lectures, examples, and cases, and a typical day is going to include a lecture for about half the meeting, and then some kind of a case discussion for the remainder of the meeting. In all cases, the focus of the course is going to be on identifying, when we're talking about our cases or our examples, the focus is going to be on identifying an appropriate method for a given situation, being able to interpret the output from the various models that were discussed on the previous slide, and also being able to critically appraise the models. So if somebody that you're working with or somebody who's working for you was to present you with a logistic regression that uses a certain set of variables to forecast something, would you be able to understand what they have done, and would you be able to be critical about the strengths and the weaknesses of the model that they've given you? When I say that we'll be doing cases, the cases will be used to illustrate the concepts in a business setting or in a business context, and we'll be using a number of cases from big case schools including Ivy, Harvard, and Darden. So in addition to the cases in the textbook, we'll also be using a piece of software called Excel Miner. So most of the examples or everything that I'm going to be doing will be done in Excel using the Excel Miner add-in. And when you install the Excel Miner add-in, you get an additional tab on Excel corresponding to the Excel Miner tool. And then within the Excel Miner tool, there are a number of options corresponding to the different types of things that you might want to do. So on this particular screen, I've got an example from the book on developing a method to predict the formula for used Toyota Corollas. And so you might, for instance, want to use the Excel Miner add-in to perform a linear regression analysis on this data set, which is illustrated here. And then there would be additional tools within the linear regression for doing that. Excel Miner, as you can see here, has a number of different tools for doing prediction, and also a number of different tools for doing classification algorithms. And so all of the tools that I would want to illustrate and discuss in this course can be done through this piece of software. The textbook that we'll be using for the course includes a time-limited license for using this piece of software. If I think about where this fits in, let's say, a data science process, I have mapped out here what I would consider to be a typical data science process, going from recognizing a problem to doing some R&D on the problem, to prototyping, to development, to implementation, and then at the far end to use and interpretation by managers. And the heavy red arrows are intended to illustrate where along this spectrum this course is going to be most relevant. And so as a course intended as data science for managers, it'll be heavy on the front end, the problem recognition, and some of the basic R&D that you would need to understand the problem and think about how you want to set it up. And then again, it would be heavy at the back end, thinking about how you're going to interpret the problem, how you're going to interpret the results, roll it out, and act on them, and so on. The course will cover a number of industries and functional areas, and so we'll draw examples from finance, from healthcare, from technology, from food and beverage, and so on. And it will also cover a number of functional areas, mostly finance, marketing, and operations. And so here I have 3 examples that we'll be talking about in the course. So example 1. We have a case study of a restaurant that has a number of existing locations, and they're looking to expand into new territory. So you could think of some kind of a franchise restaurant that has already set up in a number of locations, and now they want to make the best decisions about where they should go next. For each of their existing restaurants, they've got information about the demographics and the competitive environment in the local area. And what they want to do is to identify the locations, using that information, identify new locations that would have the greatest likelihood of success for installing their future locations. Example 2 is about managing customer churn. And this particular example is an online business which records information about the type and frequency of all customer interactions with the site. What they want to do is to determine which factors are associated with churn. So can they tell based on how long you're interacting with the site, or how long it is between your interactions with the site, or the types of things that you do when you are interacting with their site, whether you are highly likely to churn, that is to leave their site and move over to a competitor. So the idea of the case is to identify the factors that are associated with churn, and then think about, as a manager, what you could do to take corrective action for those customers who are at highest risk of churning. A third example that we'll be looking at in the course is routine screening for chronic health conditions. And the way this one works is there's an insurance provider that's gathered data on several thousand of their clients. Their data set includes information about the presence or absence of some particular chronic condition that they code as a 0 or a 1, and several other biomarker measurements and risk factors. What we want to do is find out whether we can predict whether or not somebody has a particular chronic condition given their set of biometric measures. This is important to us as the insurance company because it lets us know which customers should be referred for further screening. Further screening may have costs associated with it, but it would be a better gauge of whether or not somebody actually has the chronic condition. And so there are some cost trade-offs to be considered in making this referral decision. So as a modern manager, why do you need to know this kind of thing? So first of all, data and big data are everywhere. And one estimate that I read recently said that 2.5 quintillion bytes of data are created every day. A recent survey by the accounting firm KPMG found that 99% of the respondents in their survey identified analytics as an important part of their strategy moving forward, suggesting that the managers in these organizations need to have a solid grasp of analytics. And in terms of your career, on any project involving a significant data analysis component, you would have to be able to ask the right questions, which means understanding the models, understanding the problem, and so on. Being able to interpret the results that are generated by others, and being able to communicate your results to people who are not necessarily trained as data scientists. So summarizing, this course is going to cover several techniques that are commonly associated with data science and data mining. The coverage is relevant to the use and decision-making by managers. Focus in the course is going to be on identifying appropriate methods for a given situation, interpreting the output from each model, and being able to critically appraise models that are produced by others. We'll draw examples from a number of different industries and functional areas, and there are a number of reasons why managers in any data-intensive company or industry should want to know this stuff. And that is everything. So if there are questions, I can try to answer them.
So if anyone has questions, please raise your hand so that we can unmute you.
One question, Professor Zarek, I have is, how is this course going to be different from a regular machine learning course?
How would it be different from a regular machine learning course?
Mm-hmm.
So I would see a regular machine learning course typically as being heavy on the algorithms, heavy on the theory, and perhaps not going into a lot of detail on some of the applications. What I will be doing in this class is a little bit lighter on the theory, so this is not intended to be a theory course. This is intended to be a course that gives you a lot of intuition about the way these algorithms work, and a lot of intuition about when you want to use one of these, what you can do with them, what are the strengths and the limitations of the various algorithms in different settings. And then because we're complementing everything with case studies to get some, let's say, maybe a little bit more flavor for a real-world application of these.
Okay. Another question I have is the data sets you're going to use for these courses. This course, these are your data sets, or they come with the course textbook?
So some of the data sets would be included with the course textbook, and then some of the data sets would go along with the case studies that we would be using. So I mentioned that a typical class would include a mixture of a lecture and then a case study to illustrate. And most of the case studies that have been written in this area include some kind of a data set so that you can practice or investigate one or more of the techniques in a particular setting with a data set.
Yeah, thank you.
Okay. Any other questions?
So if there are no questions, let's thank Professor Greg Zarek for his time. And this seems to be a very interesting course especially for senior people, like those who want to understand what is going on in data science stream these days. This has become a big buzzword. And as you also said that a huge amount of data is generated everywhere, even in education. So yeah, this will be an interesting course.
And
thank you, Professor Greg.
Yeah, I'm surprised. I never knew that you can do all these algos you can run these kind of regressions in Excel. I thought like only you can run like one variable regression in Excel, and I think the standard Excel comes with one variable regression.
Actually, standard Excel, you can do, I believe, up to 16 variables. Okay. But then this is an add-in. So there's a company called Frontline Systems that has built this add-in specifically to do this particular task. And I think their vision of this add-in would be similar to the way I've illustrated it in the data science process, right? That it's really, really good for exploring your data set, for getting an understanding of how your data set works and so on. But ultimately, as you move to implementation, you would want to move to some other package or environment. But great for understanding your data set and the limitation of the various methods. The other thing that I would just say too, it was just mentioned, this is good for senior people, and certainly that's my pitch is, this is data science for managers, and we're looking at it as a course for senior people, but I think there's also a lot of benefit to taking this to build up some of your intuition if you're thinking about taking one of the more mathematical or more technical courses that comes later on, right? And then when you see things, and some of the matrix algebra and so on that goes on behind the scenes, you have a solid grounding on when and why you want to be using those things.
Yeah. Okay, thank you. Thank you very much, Professor Greg.
Okay, thanks.
Thank you. So I will change the presenter. I will make myself presenter. So since we are already towards the end of our time, so let me just summarize the discussion on sequences. Okay, so sequences allow us to do operations on these different types which are very similar in nature, And this is one of the strengths of Python, that you can replace one type by other without changing a lot of your program. Okay, and you can try with different types of sequences and see what works best for you. The examples that we saw are of indexing, where you can find out element at a specific position. We can figure out number of elements in a sequence. We can do concatenation, repetition, and slicing. Okay. Few examples which we did not discuss in lecture, but I remember Prasanna doing them in tutorial, are the in operator. So you can ask whether a particular element E is in a given sequence or not. So it returns true if E is present. It returns false otherwise. Okay. You can also ask the reverse question, that whether E is not in sequence. And finally, the use of this in operation is mostly in for loops, where rather than going over index of the sequence, you can directly iterate over elements in the sequence. Okay, so in this case, as we have been seeing in case of range function, whenever I say for E in sequence, E will get bound to one element of sequence at a time. Okay, so if the sequence is ordered, the binding will also follow that same order. So sequence types, as we have seen, they include strings, tuples, and lists. Lists are mutable, tuples and strings are immutable. Okay, and there is lot more to sequences that than we have discussed. In fact, it's very difficult to cover them as part of the class. So I suggest you go over this particular link, or in general go through Python documentation whenever you are in doubt. So this particular link discusses about the data structures and some functions and their semantics. Okay, but remember, there is no substitute for actually practicing and writing programs. So with that in mind, I open the session for any questions. And I request you to do quiz number 27 and 28 as homework exercise. Okay. So I'm unmuting all so that we can have any questions or comments. So if there are no questions, then we will stop here. Thank you everyone for attending this lecture, and thanks Professor Greg for joining and giving us the teaser for his course. Okay, bye.